Hello everyone, this is Kanu Butani here and welcome all to my blog. Today we will be seeing what is everything about digital twin. This is very important when we consider the oil and gas industry or big industries like utilities and uh, energy or transportation. As you can see, the aeroplane figure here, and there is the uh, parallel or another aeroplane figure. This is called the digital twin of this plane. So we will see all the things about digital twin, which is a very important topic. The agenda for the day will be what is digital twin, why digital twin, where do we use digital twin technology, when to use it, and what are the components, and finally how we can use this digital twin. So what is digital twin? It is a virtual representation of a physical object, a process, system, or entity. It is a digital counterpart that mimics the real world counterpart with a high level accuracy. This concept emerged as a result of the increasing integration of digital technologies such as the Internet of Things, which is called IoT, advances data analytics, and simulation software with physical objects and systems. So, here are some of the key aspects to digital twin. The first one is accurate representation. So a digital twin represents or is designed to closely monitor or mirror its physical counterpart. This includes not only the object's geometry but also its behavior, performance, and interactions with other objects and the environment. The second is real-time data sync. So the digital twins often receive real-time data from sensors and other sources which are embedded in the physical counterpart. This data is used to update and refine the digital twin's state, allowing it to simulate the real world object's current conditions and responses. The third one is analysis and prediction. So, with the data that is collected from the physical object, this can be used for various analytical purposes. It can predict the behavior, it can simulate the scenarios, and model potential outcomes based on different inputs and conditions. The fourth one is monitoring and maintenance. So, in this, we use the digital twins for continuous monitoring and maintenance optimization. So, by analyzing the real time data that we get and comparing it to its expected behavior, anomalies, and potential issues, this can be identified early and enable the proactive maintenance. Then comes simulation and testing. So in this, the digital twin is used to simulate and test the different scenarios without affecting the physical object, which is very important here. And the valuable in fields like manufacturing, engineering, or complex systems like power plants or transportation networks are particularly used. And then is life cycle management, where it covers an object's entire life cycle from design to development to operation to maintenance, providing insights and data throughout its existence. And the collaboration and communication is one thing that is the digital twin helps in better communicating with the different teams and stakeholders like engineers, designers, operators, and maintenance personnel that can collaborate using a shared digital representation. So, in this way, you can find the applications with digital twins in various industries like including manufacturing, healthcare, energy, aerospace, and more. In oil and gas industry, for instance, it could represent an oil rig, allowing engineers and operators to monitor its performance in real time, simulate the different operating conditions, optimize the maintenance schedules. So this is an important to note that the concept of digital twins continue to evolve and its potential applications are expanding as technologies are advancing. Moving on further, why digital twin is used. So digital twins offer several compelling benefits across various industries and sectors, and there are some key reasons why organizations use this. The first one is predictive maintenance. So by since we are having the real time data for a physical asset that we have and we are having the digital twin model of that, the organizations can predict the maintenance easily and approach the reduced downtime, expand and extend asset lifespan, and optimize the maintenance schedules. The second one is improved decision making. The digital twins provide a virtual platform for testing different scenarios and strategies. This allows organizations to make informed decisions based on the simulations and analysis, reducing risks and improving outcomes. The third one is reduced costs, which due to the proactive maintenance, accurate modeling, and simulation capabilities, it really helps saving the costs and prevent expensive repairs or replacements. Then comes efficiency and optimization. The optimization of processes, operations, and systems are done or enabled by the organizations since they can really identify the most efficient ways to use resource, energy, and time. Then it's remote monitoring and control. Since the physical access is very limited, risky, the or at the remote area, so the digital twin provides the monitoring and the controlling of assets sitting in the office, so particularly the offshore oil rigs where real time monitoring is crucial, so that happens here. And the next one is quality improvement. The digital twins allow to monitor the quality and performance of the product, and hence it is valuable for maintaining consistency and product quality and improving design and manufacturing process. The next one is innovation and prototyping. So, since digital twins are used in research and development and innovation, the engineers can create the prototypes to test the ideas, iterate quickly, and refine designs before committing to physical production. Training and knowledge transfer. Yes, this provides a safe environment for training personnels. The new operators and technicians can learn to handle the complex equipments and processes without damaging or risking the actual assets. Then it's regulatory compliance. The digital twins help organizations maintain compliance with industry regulations and standards by monitoring the and recording the data. Organizations can demonstrate and adhere to requirements. Then comes sustainability, which is a very important aspect nowadays. The organizations are there to assess the environmental impact for their operations, the simulation and simulating the different practices and scenarios to reduce the energy consumption and waste. Then comes collaboration. Collaborating digital twin facilitates multidisciplinary teams, the engineers, the designers, the analysts, and other stakeholders can work together on a shared digital representation, enhancing communication and understanding. So, after that comes real time insights. The digital twin provides the real-time insights to the asset performance, enabling faster and more informed decision making. This is particularly beneficial for the industries that are rapidly changing in the conditions. So that is required at that time. And then comes the risk mitigation, which is simulating the potential risks and emergencies where the organizations can plan contingency and response strategies, reducing the impact of unforeseen events. Overall, digital twins offer a holistic approach to manage assets and processes. They bridge the gaps between the physical and digital world, which is very amazing and enabling and reducing the costs. Then comes when we can use digital twin. So these can be used in various situations and across multiple industries. The first one is design and development. The digital twins can be used in designing and development phase of a product or a system. The engineers can create a virtual prototype and test and refine them, and this helps in identifying the potential issues early and reducing the development time and costs. Second is manufacturing, wherein the allows the organizations to optimize the production lines and workflows, and by analyzing different scenarios, it can improve the efficiency and reduce the waste and enhance the quality control. Third is operations and maintenance. The real-time data from sensors on physical assets can be used to update the digital twin model and enabling the maintenance and minimizing the downtime and reducing the maintenance costs. Fourth is the asset management like Maximo, where the complex assets like industrial machinery, infrastructure, and facilities are there, and here it provides the performance and condition throughout its life cycle. Then comes healthcare. In healthcare, it models and simulates the human body, which can aid to the personalized medicine, treatment planning, and medical research. Then comes aerospace and automotive. These are the industries where they design validation, aerodynamics, simulations, crash testing, and more. And the engineers refine designs and assess performances without the physical prototyping. Then it's smart cities. The urban planners use the digital twins to model and manage city infrastructure, traffic flow, energy consumption, and public services. It also enables the resource allocation and responsive urban development. Then comes supply chain management. The supply chain management operates by simulating demand, production, and distribution scenarios. This also helps prevent bottlenecks and improve overall supply chain efficiency. Then comes environmental monitoring, where the digital twins model and predict the environmental changes like climate patterns, pollution levels, and ecological impacts. Training and simulation is another one where the technicians and emergency responders are provided with a safe environment wherein they can practice the different scenarios and procedures without risking the real world assets. Then it's research and development, wherein they are used to simulate and study complex phenomena such as molecular interactions, weather patterns, and chemical reactions. Next is real time decision support. The dynamic and rapidly changing environments, digital twins provide real time insights, helping the organizations to make the informed decisions quickly. The next one is complex systems, wherein they are used to model and understand intricate systems with multiple interacting components such as power grids, water distribution networks, and industrial processes. So here the decision making is uh, depends on the specific goals and challenges of an organization or a project, and it is benefits for a real-time monitoring, simulation, predictive analysis, optimization, and aligning with your goals and objectives. So then we'll see now where to use digital twin. So the digital twins can be used in wide range of industries and applications, as we are continuously seeing here. So the some commonly employed places are, first is manufacturing and industry, in which it's factory operations, which helps optimize manufacturing processes, monitor equipment health, and streamline production lines. Product development engineers use the digital twin to simulate and refine product designs before physical production. The next one is energy and utilities, in which power generation is the place where it models power plants, enabling efficient energy and production and predictive maintenance. Then it's smart grid, wherein it simulates the power distribution networks to ensure reliable and optimized electricity delivery. Then it's renewable energy, wherein it optimizes the performance of solar farms, wind turbines, and other renewable energy sources. The next is aerospace and automotive, and the first one is aircraft and vehicle design. The digital twins support aerodynamic testing, structural analysis, and design verification. Then it's vehicle performance. It simulates the vehicle behavior, aiding in improving fuel and efficiency and safety. Next is healthcare, patient-specific treatment, where it models individual patients' anatomy and conditions for personalized treatment and planning. The medical device design, where it helps design and test medical devices, improving their efficacy and safety. Infrastructure and construction. The first one comes building design. It optimizes the building designs for energy efficiency, comfort, and functionality. Then comes smart cities, wherein it models the urban infrastructure, aiding in urban planning, traffic management, and resource allocation. Next is oil and gas. The first one in it is offshore operations, wherein digital twins monitor offshore platforms, predicting maintenance needs and ensuring worker safety. The asset management, wherein it manages complex asset equipments and the infrastructure across the oil and gas supply chain. The next is mining operations and natural resources. So mining operations, it optimizes mining operations, improves safety and enhance resource extraction efficiency. Then comes environmental monitoring, where it models the environmental impact and help in sustainable resource management. Then comes retail and consumer goods, in which the first one is inventory management. It aids in tracking and optimizing inventory levels and supply chains. Next is store layout and design, wherein digital twins help design store layouts for better customer flow and product placements. You can see this in the automation robots that are used in Amazon stores and Amazon warehouses, wherein they go and pick up the things on their own. So that is possible when we have proper store layout and design stored in those robots, and then they can work accordingly. Transportation and logistics. The first one is fleet management. It monitors vehicles in real time, optimize routes, and reduce operational costs. Then is logistics planning, digital twins, model distribution networks, enhancing delivery efficiency. Then comes defense and military. First is simulation and training. The digital twins simulate battlefield scenarios and aid in training soldiers and strategists. Then it's equipment maintenance. It predicts maintenance needs for military hardware, reducing downtime. So these are just few examples where we can use digital twins. The flexibility and versatility of this makes it relevant in various industries where real-time monitoring, simulation, and data-driven decision making are essential. So it's an industry's unique challenges and goals. And now we will see the components of digital twin. It consists of various interconnected components that work together to create a virtual representation of a physical object, system, or process. The components can vary based on the complexity and purpose of the twin. So some of them are, first one is physical asset. The physical asset is a real world object, system, or process that the digital twin represents. This can range from simple objects like machines to complex systems like manufacturing plants or even entire cities. The thing that you can see when the Google Maps, they are all mapped due to the digital twin technology. They are mapped, and then we can route through that maps with the entire cities. Second example is that when you go for a wheel alignment for your car, so the wheel alignment is happened through a machine wherein the same wheel of your car is been digitally twinned in that machine, and then the operator or the mechanic uh, aligns your wheel by looking into that machine and putting the values accordingly. Then is sensors and data sources, where they are used for real-time data from the physical asset. These sensors could measure parameters such as temperature, pressure, vibration, location, and more. Third is data integration and aggregation. So data from various sensors and sources need to be aggregated and integrated into a unified format. This often involves data pre-processing, cleaning, and transformation before it can be used to update the digital twin. The next is IoT connectivity. The Internet of Things connects the devices and networks with the sensors and other data sources to the digital twin platform. This enables the continuous flow of real-time data. And then is modeling and simulation. We have been reading this throughout, that how this involves by creating a virtual model that mimics the behavior, the characteristics, the interaction with the physical asset, and advanced modeling techniques including physics based modeling and machine learning can be used to create accurate presentations. So see how we can integrate the AI and machine learning and AI tools in this. Next is real-time data processing. The We are actually concerned with the real-time data processing, what on the time, that is very important. On time data, we are not concerned about mostly about the historical data, but here the real time data processing should happen properly from the sensors as they are processed and used to update the digital twins model. So this process can include the anomaly detection, predictive analysis, and trend identification. Next is visualization and user interface. Yes, this is very important because the user interface is required for a person to interact with digital twin. As you can see the image also, this is the user interface which is required, wherein we can understand the visually appealing manner, the allowing users to monitor and analyze real-time data. Then comes analytics and decision making support. So the analytics of the tool, to analyze the data collected and provide the insights and predictions, and finally the informed decisions about maintenance, operations, and optimizations can be taken in. Next is cloud computing and storage. Yes, we have to do the cloud computing and storing capabilities, because to make the scalability and see that these data processing, storage, and accessibility are happening through cloud. to make it more easier for the technicians and the engineers who are working on site to retrieve this data easily. Communicating and collaboration. The digital twin platforms need to communicate and collaborate with the that allows the multidisciplinary teams to work together and useful for remote collaboration and troubleshooting. And finally, with this, we come to security and data privacy, which are very important because such a sensitive data, when we are passing it through the digital twin, we have to regulate it and compliance should be considered. And then life cycle management, the entire life cycle should be covered of a physical asset from design to development to operation and retirement. Managing updates, changes, and improvements to the digital twin model is important. So, hence, these components work in harmony to create the dynamic and interactive digital representation of a physical asset, enabling better decision making, predictive maintenance, optimization, and innovation. How is digital twin used? The digital twins are used in various ways depending on the industry, application, and specific goals of an organization. The first one is design and development. The engineers create digital twins to simulate and test product designs before physical production begins. This helps in potential issues identification early and reducing the development costs. Predictive maintenance. The real time sensor data helps in predicting the maintenance needs and minimizing the maintenance costs. The third one is performance maintenance. Yes, we have seen how to optimize the performance of systems, processes, and assets, leading to increased efficiency and better resource utilization. Then simulation and testing, which is again a very important thing, wherein we try to test the real time conditions and the different scenarios in it. And this is used in industries like aerospace, where aerodynamic simulations and crash testing can be performed virtually. Then comes remote testing and monitoring and control, wherein the hazardous environments digital twins enable real-time monitoring and control of assets from a safe distance, and this particularly happens in industries like offshore oil rigs. And then comes health care and medical research, where the digital twin models individual patients anatomy and conditions to aid in treatment planning and medical research, such as simulating the effects of different treatments on a patient's body. Process improvement. It helps the organizations to analyze processes and workflows to identify bottlenecks, inefficiencies, and areas of improvement. Supply chain management for inventory management, production scheduling, and distribution strategies. Smart cities and urban planning for traffic control, infrastructure, resource allocation, and smarter cities. Training and simulation for the military personnel can practice operations and maneuver virtually. Environmental monitoring and sustainability for helping organizations assess the ecological footprints and make more sustainable decisions. Quality control for quality product maintenance and simulating and analyzing production processes and their impacts. Innovation and prototyping is used for testing new ideas, concepts, and prototypes quickly and cost effectively. Real time decision support is used for supporting quick and informed decision making in rapidly changing environments, and emergency response planning for developing effective response strategies, enhancing preparedness and safety. So ultimately, this is used in each and every industry that offers a versatile approach to improving efficiency, reducing costs, enhancing safety, and making data driven decisions across a wide range of applications. Thank you very much. I hope this session would be very useful for you as I've covered the entire thing of digital twins. Thank you. Bye bye. Have a nice day.